Now let's try to build a bottle by only using side profiles and the Revolve tool. So we can, for example, start with the EP. Maybe in our first step, control, click, click. All we need is just a line. The next one, actually, we need to at one point use the align tool. So I need more control vertices, so a degree 3. Now the next one here, this is going to be an interesting step. So we can, for example, maybe say degree 2, control, edit point, control, edit point, control, edit point. Okay. And let's click on it and see. So it's a 2 span, 2 degree. So you see, think about like the edit point when you draw it, it's like a straight material, and the edit points push and bend it. So it really feels like from there to there that this one is pushing this arc out. Now I could also say, for example, with maybe a degree 2, click, click, and click, I create this curve, and nope, I do not want to draw a new one. Object, here, don't show this control vertices. There's a control vertice from that one curve. And now I can, for example, by hand adjust it. So you see, I can actually get exactly to, well, I don't want to say exactly, but I can get pretty close to the same flow with a much simpler geometry. Later, in case I would have to change this one, it's just one control vertex I need to move, while with the other one it's a more complex surface. Again, that is the difference between what I did first, dirty modeling, but what you can do to quickly get an idea how things maybe should look, and then class A surfacing, meaning you take your dirty model and put it through a diet and basically rebuild it with the least amount of points as possible. And the main reason for that is also this data later has to be passed to the engineer. This has to be passed to, for example, the mold making people. They have to CNC the molds. And in case somewhere something has to be adjusted, the last points they need to work, we have to adjust, the easier it will be. So this means this I'm for the moment going to hide, because this one I'm going to delete. And visible, there it's back. Okay, now let's go to CV and maybe 5. Control click down there. And now I need at least 1 or 2 points out, so I'm already clicking this one there and there. So 2, 3, Alt 4, Alt 5. There's my curve. And then, for example, I can go ahead and actually start maybe moving these points a little bit. I'm not going to spend too much time, because now I'm actually going and use the align tool. Down here, I would like maybe G1 continuity. There, pulls this one out. Perfect. Next, here, for example, U to U, and this end to this end. Next. Now, this is just only G1. G2 might actually be better, of course, but then I would need more points, just so that it's a little bit less dense with geometry points. I'm going to use G1 for the continuity at the moment. And let me select and select, turn off those points. Okay. And for example, here maybe, now this is all a little bit off, so the ball is slightly too high, but maybe I simply leave it. I'm going to see if maybe I can adjust this tiny bit. make this transition smaller. Right mouse button, control, move to this point. You see it snaps. Another nice thing of working inside orthographics. Perfect. Okay, good. So this is not going to be a nice transition down here. That I know, because this is a really small area for how quickly this stuff has to bend. But we will see how this is going to look. Okay, so I think we are pretty close to make our first revolve. And we can go to Revolve, turn on chain, global, Z. So here we are back, alias crashed. And before I go into the Revolve tool, I would like to stress again that actually for all those profiles, I set my pivot point. So easy way, top, Alt, move it around, go to the center, and all curves got their pivot point snapped here. And this pivot point, for example, lines up with this vertical line, which, for example, in our case symbolizes the z-axis. Think about a wood lathe. Those profiles will be rotated around this axis. So if we then go into Revolve and local z, yep, select, next, select, next, select. Didn't it create? Yeah, no, it did not. Next, there, next, there. Okay, so there are our Revolve surfaces. And at this point, maybe I would like to introduce to you the diagnostic shading. You notice that sometimes when you zoom in and zoom out here, you can see it nicely shaded, and here it's kind of grayish. So that can be annoying. But actually, you know what I mainly use is, I use this one. So I set everything off. So wireframe, and then here, this way you can show it shaded and non-shaded. Here, for example, you also find interesting shading modes, for example, the zebra, or for example, this one, or this one. And they're pretty much useful for rotating your view. And you pay attention to how, for example, your highlights change. So let's zoom in. Let's go to this one. Till I see what I would like to show. For example, there, you can see that a little bit, or the zebra. And you see that this is a little bit triangulated. You can also work with the tolerance, then it's even worse. So you see like big gaps. Now those gaps you see are not really holes inside your surface. A NURB surface cannot be represented because it would be too computation intensive. So the software is creating a very coarse polygon mesh, which then can be shaded. And that's actually what this tolerance is doing. You see, based on how I play with this, you have a better quality. So that's, for example, the visual diagnostic shaders. But those are, yeah, maybe okay for some play around stuff, but they're not really very, very accurate. So let me show you now how we actually measure this one and make sure that this is a good surface, because currently this all shades nice and soft. But when we go to evaluate, dynamic section tool, double click it. Let's select this surface, this one, this one, and this one. See, there's a small thing you can move, rotate, and you see those red lines. Maybe I try to only have maybe 4, maybe space them out more. Trying to see maybe if I can get it so I have on each surface, maybe 1, or maybe actually simply 3 there. Okay. And then down here is a curvature on. And if I click it, I have my samples, I have my scale. So you see there's actually the curvature graph projected on the surface. And if we set this one really fine, it looks good. But if we zoom in, you see there's something going on. So for example, there specifically it's bad. See, this is flat. So why did it happen? Actually, the reason there is very simple, the way how we set everything up. What we can do actually to fix this also, for example, to make sure the fillet command, surface fillet, will later work, is because this is a closed surface. So you see one edge, edge, edge. Here's the back surface. So what we have to do is actually simply go and select our object, go to Revolve, and turn this one to periodic. You can also select query there, periodic. Okay, for example, fine. And let's go back to here. 1, shift, shift. Let's go to a side. Let's move this one up. Let's turn curvature on. And let's take a look. And you see this looks now nice and round, circular, the way how it should be. So never trust shaded models. They always look nice, but sometimes they can be not really ideal. So here we, for example, had a somewhat good looking model, but then changed the settings so that the surface is more even. And again, don't trust those shader models. They can be good for some really coarse problems, but then make use of the dynamic section tool, or for example the curvature comb for curves here, to make sure that your stuff is in good quality.